Hi, welcome to another video tutorial from Robojax. In this video I'm going to introduce the L293D motor controller chip. This is one of the widely used chip for robotics and motor controller. I've set it up here that it can rotate the motor in both directions. As you can see, when the LED is green, it rotates in one direction, and when LED is red, it rotates on the other direction with the same L293D chip using Arduino. You can get the code for this project by clicking on the link in the description, which will take you to robojax.com/learn/Arduino. So let's get started. I've provided two types of code for this project. One would be just simple one to run this, and then the other one will be a little advanced to give you more option and easily use it within your application, so you don't have to change the whole code. Just simple command will change it. This chip is offered also as a module, something like this, to control two motors, and also this is offered as a shield here like that. But if you are using it for stepper motor, that's a different thing, which I will cover and create separate video for this. So now let's have a look at the data sheet. The chip is from Texas Instrument, and they have two versions of this. One is L293 and then the other one is L293D. L293 can handle 1 ampere per channel. So L293D can handle up to 600 milliampere for the motor per channel, and so the voltage supply can be from 4.5 to 36 volts. So that's very important to know that your motor cannot exceed this. So the peak current can go up to 1.2 ampere, but for continuous operation 600 milliampere is important. So this has been described very well here. So this is the IC, and this is the notch, and from the left 1 to 8 and then 9 to 16, and these 3 pins are for one pole, and these 3 pins are for the other pole, these 3 on this side for the other pole, and then we have this 2 for the other one. So the enable for the 2 on this side is at the top, and the enable for the 2 is on this side. This one we have here as VCC1. This is a VCC logic, which is VCC1, which you supply 5 volts. That is for internal calculation and logic level detection. And then VCC2, this one can be of 4.5 to 36 volts. These are the poles. So we have 4 poles. So we can use this as one junction, 1A and 2A. These are the inputs, and then we have 1Y and 2Y for the outputs, and these two together can be enabled via pin 1. So 1 and 2 can be enabled. If you set this high, so this 2 pole will be both enabled, and if you set it low, they will be disabled. So same thing for the other one. Rotate the motor into one direction, we can use one of the pole only, and motor will rotate in that direction. Each pole one motor, total will be 4 motors can be controlled with this. But if we want to change the direction of the motor, we can control only 2 motors using all the poles. Here is one example of using this pole and this pole. So this will be high and this will be low, and the motor will rotate this direction. The 2 pole that can be the output of the one pole, and the output of the other pole is connected to the 2 pin of the motor. Will be provided. The link for the datasheet will be provided at the description. So here is how the DC motor works. You connect a battery to the 2 terminals of the battery, plus and minus, positive and negative, to the 2 terminals of the motor, and it will rotate the direction either clockwise or counterclockwise depending on the motor. So let's assume this is just going clockwise. So the current will come, goes through the winding and comes back, and the motor will start rotating. Now if somehow we are able to switch these cables, connect that red in here and the black there, it will rotate the other ways. So here is the solution for that. So the current goes as before this way, and the motor rotates clockwise. The current comes back, this is a switch. These two poles are connected together. So the current goes this way and continues. So the motor rotates the other way. If we change the connection instead of that to this 2, now the current, instead of going the positive going that way, it comes through this, it goes to this polarity. So we have switched the wire that was going there, we switched it here. And then inside the motor, it comes back. This time through this switch, it goes here. So now the motor will rotate in reverse. So here is a clockwise rotation. So the positive is at this terminal and negative is here. And this is switched now the other way. So the positive connects in this line, and that's the output. So this will be clockwise rotation, and this will be counterclockwise rotation. And here is the LM293 motor direction. So we have one motor driver element, and then we have another one. We have two pieces. So 1A has an input, and 2A there is another input, and the output is 1Y and 2Y. So the enable is common between both. So if we put it high, both of these will be enabled. If put this pin low, both of them will be disabled. So we put this always high when we want the motor to rotate. And now we left with the direction what to put in 1A or 2A. So here we put the 1A. If we put the 1A low and 2A high, so the positive will come to this direction, and then the exit will go to the negative from the Y2. So Y2 will be positive, Y1 will be negative, and the motor will rotate this way. Now if we change the 1A high, you see that we switch these, and 2A low, then the positive comes this direction and exits and goes to the 2Y, and the motor rotates clockwise. So by selecting the inputs as high or low between 1A and 2A, the motor will rotate clockwise or counterclockwise. So here are the wiring. We have set this for the ground, and then this, the red one, is for the 5 volts. So this is connected to the ground of Arduino, and this is connected to the 5 volts. And for the chip, it's very easy that after this is pin 1, 2, 3, and to 8, and then from here 9 to 16, and this notch help you to understand it. So after the third pin, pin 4 and 5 are connected together, and it's connected to the ground. I have connected that ground with this green wire here, and also these two are also connected together and then connected to the ground. That's done. Then so this VCC 1 is connected to 5 volts. That's a logic reference, very important. But then VCC2 can be connected to from up to 36 volts, from 4.5 to 36 volts. And because I'm using a very tiny motor that needs very little current, I've connected this to the positive. As you can see here, I've connected it here to the positive, which is connected to the 5 volts. But we can remove it later on. I'm going to show you. This is the enable pin. The pin 1 is enabled. This is where you can turn on the motor on and off. So the enable pin is connected to pin 8 of Arduino. So this is connected to pin 8. This is enable pin to turn the motor controller on and off. And this is the input of 1A. This is connected to pin 2 here. And this is for 2A. This is the input of the second portion that controls the motor. And this is connected to pin 7. So what I've done is the pin 2 of the IC is connected to pin 2 of Arduino, and the pin 7 I've connected to pin 7 to make it easy. So these 2 and 7 are the input. Then the motor, for the motor I've put these wires here. The motors I can connect it depending on the direction of rotation. So I've connected the motor here to the pin 3, which is 1Y, and pin 6, which is 2Y. So let me explain the code here. So this area is for motor 1, and here we say 1A, pin 1A is number 2, so that will be connected to pin 1A, and pin 2A will be connected to 7, and then enable 1, 2 will be connected to pin 8. So we are using 2, 7 and 8 for one motor. And then in case you're controlling second motor, I've put also 10, 13 and 9. So we will use P1A and P2A instead of 2, 7 and EN1 and 2 instead of 8. Here is the loop, the setup. Inside the setup, we initialize this serial monitor with 9600 baud to print this, and 9600, if you're wondering, is the number that is in this corner. It must match. And then we say pin 1A, pin 2A, enable EN12 should be all as an output. So we are not getting anything from motor, but sending command or information or value to motor. And then these are for the motor 2, which I have not used, but I've just defined it here. After that, we have a loop, which ends here. So first, I'm printing this rotating in C direction, so that is this text. And then we say digital write EN2 equal 12. So first we have to enable the pole, the two pole 1 and 2, we say high. So when we say digital write EN1 and 2 high, so that pole 1 and 2, which controls one motor to the positive and negative direction, it will be on. So the enable is common between both. So if we put it high, both of these will be enabled. If put this pin low, both of them will be disabled. So we put this always high when we want the motor to rotate. And then P1A should be high and P2A should be low. So that's determining the direction. So high, one should be high, the other should be low. 1A low and 2A high. So the positive will come to this direction, and then the exit will go to the negative, and the motor will rotate this way. And then P1A should be high and P2A should be low. So that's determining the direction. So high, one should be high, the other should be low. It will rotate in one direction, and then we wait for 3 seconds in that direction. After that, we say EN1, 1, 2 low. So we are stopping the motor. When we say low, the motor stops. But for how long? This determines. We will wait for 2 seconds or 2000 milliseconds as a stop mode, and then we print this on the screen, which is this text. After that, we go to the other direction. Now pay attention here. P1A was high, P2A is low. Now P1A is low and P2A is high. So we switch these, and 2A low. Then the positive comes this direction and exits and goes to the 2Y, and the motor rotates clockwise. So I just switch the places for both. Again, wait for 3 seconds, and then EN12 should be low, and then wait for 2 seconds. Exact same thing, except these two values have been switched. And at the end, we just print this loop done, which is this one, so you understand what is going on. Then you can delete it or comment this by putting the 2 / here, and then we wait 500 milliseconds and continue like that. Now the code is running, the motor is disconnected, I'm just connecting it. So you can see here the color of this. When it is red, it rotates in one direction. The green is very light, so this is due to the variation in quality of the motor, of the LED. So you can see here at the bottom, it says rotating counterclockwise, that's a green, and then it stops, loop done, and then clockwise, which is red. So the information is printed for you here. Now this is using the 5 volts from the Arduino because this draws very little current. But if I can connect it to external power, now you will see the difference. So I have connected now external power source here. So common, it doesn't matter. This matters. This is not connected to anywhere except the pin 8. So now I'm going to connect the motor and you will see the difference. Now it's very fast. So the first portion of the tutorial is done. You can use that code to use L293D. But if you want to learn about, but if you want to make it easy with simple code and advanced control over the motor, let's continue watching. Tutorial is done. You can use that code, but if you want to make it easy with simple code and advanced control over the motor, let's continue watching. This is the advanced code that you can control the motor better. This area is the same, here is the same, and then in the loop I have made some, in the setup is also the same. After that, in the loop I have made some changes. I have written a function called rotate MA, which refers to motor A. I've done it only for one motor, so you can do for the same thing. Let me go to the method and then I will come back. So rotate MA starts from here and ends here, and it has two parameters here, string di, which is direction, and integer, that's enable and dis. ANDIS, enable, disable. So this is an integer which can be 0 and 1 or high or low. And then here we have if condition, which starts from here to here. We check if di is equal CW, then we print this text, and then enable 1, whatever is enable 1. If it's high, it will be enabled. If it's low, it will be disabled. So that is here. And then we set P1A high, P12 low. So this is determining the direction of a motor in clockwise. If this is not true, then else. Here we say ENDS enable, so enable disable is the same as before, but high and low have been switched. You see P1A was high, P1A is low, P12 is low, P12 is high. So this is just for the case that if you want to rotate it left and right. And that's it for this method. Now let's see how I have used it. Here inside the loop, I've used it, and I call that function here, and I pass this CW inside the double quote and then separate it with a comma, and then I put high. When I put high, that means enable, and then CW means rotate counterclockwise. So this sends the command, and then motor start rotating, and we wait for 3 seconds or 3000 milliseconds. After that, we send low, that is disabling the motor, and then we wait for 2 seconds. After that, we say counterclockwise and high, so it means enable the motor and rotate clockwise, and then for 3 seconds, and then disable the motor, which is low. But this clockwise, counterclockwise doesn't matter. If you stop the motor, doesn't matter which way it rotates. And then we wait for 2 seconds in a stop mode before the loop continues. So this is the demo of this advanced code. As you can see, the motor is rotating to one direction, and then it stops and rotates into the other direction. Now the green is high. So now let me explain here how you use it for your application. So every time you want to use it for any application, let's say you want to control a motor if the temperature increases or some value appears. So you just say if, let's say you have a variable from a sensor or from something, integer, and we have a value, let's say val equal 45. Let's say temperature increases to 45 degrees Celsius, and a fan should start rotating. So here we say clockwise, and then whatever time you want. If you want it to run continuously, just put that and then remove all of this. So your condition should be met, and then this way you can call it. If you want the motor to rotate counterclockwise, just change this to CCW. If the temperature or a value changes and you want to stop it, just use low here. As simple as that, so you can control a motor. If you're using multiple motors, more than one motor, then just copy this, the whole thing up to here, and make it MB. So when you make it MB, everything else, once you make it MB, we have here P3A, 4A, and then ENS34. Now then in here, make this 3, 4, and then make this 3 and then 4. 1 become 3, 2 become 4. 1 become 3, 2 become 4, and here 3, 4. And the same MB will work. And when you call it, just call this MB, whatever name that you put. If you put capital B, make sure M capital B, and it will run. So thank you for watching. Please thumb up the video, please share it, and also subscribe to get updates of my upcoming videos. I will have a lot of videos related to motor. I'm preparing the material and soon record and upload them all.